Hi, this is Jay from paulpolito.com, and welcome to the next installment of our screencast series about devices, Linux file system, and file system hierarchy standard. 104.6 Create and change hard and symbolic links. In this tutorial, we will look at the difference between hard and symbolic links. After you have watched this screencast, you will know how to create links, and you should see how links can facilitate system administration tasks. The new command you will get to know is ln. Okay, let's get started. What are links about? Sometimes it is useful to have access to a file in different locations on your file system. To avoid making copies of a given file everywhere on the system, Linux uses links that point to the original file. Links take up very little space and are much more efficient than having multiple copies of the same file distributed throughout your file system. Linux uses two different types of link, hard links and symbolic links. The huge advantage of links is, if you are editing a file, the changes will be replicated automatically in all linked files. This facilitates system administration tasks enormously. If Linux were to copy whole files to other locations instead of using links, you, the user, would have to make changes in each copy manually. Hard links. Hard links are pointers to the exact same data as the original object. Therefore, hard links always share the same inode as the original object. In other words, a hard link is not really a link at all. It is a duplicate file system entry at a different location for an already existing file. Let's have a closer look at what this means. To create a link, we use the ln command. The syntax of ln is straightforward. ln, target, link name. In the following example, I will first create a test file in my home directory called hardlinktest. Then I will create a few hard links in the /temp directory which point to this file. Now, let's check the link's inode numbers in both directories. To do this, we use the command ls-li. Indeed, the file and the hard links that I created all share the same inode. The number 4 we see here is the link count number. It tells us that 4 files are currently sharing this inode number. Now let's delete one of the links and run the command again. As expected, the link count number, now 3, is 1 less than it was before. What we have actually achieved by hard linking the files to each other is that making changes to any one of the newly created files will write the changes to all of the linked files. Let's check this out now quickly. If you delete a hard link, or even the original file with which it is associated, the one in my home directory, the remaining hard links will still operate. Let's have a quick look. As you can see, the link count number is now reduced to 2. So, if we would delete the last two files, hardlink test 3 and hardlink test 4, all content definitely would be lost. There are two important restrictions concerning hardlinks. Firstly, hardlinks to a file must all reside on the same file system. Secondly, hardlinks can only point to files, therefore they may not point to directories. If you need to know which files link to a particular inode, you can use the find command with the -samefile option in combination with the file name. You may also use the -inum option of the find command in combination with an inode number. We will discuss these examples in more detail in an upcoming screencast. Symbolic links. A symbolic link, also called symlink or softlink, is a pointer to a file name in its original location. Essentially, a symbolic link is nothing more than a path to a file. Consequently, if the original file is deleted, all symbolic links pointing to the original file become broken or stale. Symbolic links will no longer function when the data of the original file is lost. You create a soft link by using a command you already know, the command ln. Use the -s option with the ln command to create a soft link. In contrast to hard links, you may link to both files and directories using soft links, and soft links may also point to locations on other file systems. Now, let's have a look at a simple soft link example. I am attempting here to access the /etc password file located in my /etc directory without leaving my home directory. Normally, I would have to switch to the /etc directory first in order to open the file password. But by placing a soft link to /etc password in my home directory, I will be able to access the file directly without switching directories first. Here, I create the link. This is the link which points to the file /etc password. The first letter in the left column, the L, specifies that the link is a symbolic link. The arrow on the right side is the pointer to the original file. Now, let's open the file /etc password using the new soft link in my home directory. Looks like our new soft link is working just fine. Summary. To avoid having to make multiple copies of the same file when it is needed in different places on your system, Linux uses links. Linux makes use of two different link types, hard links and symbolic links. Hard links are pointers to the exact same data. Therefore, hard links always share the same inode with the original object. To create a link, we use the ln command. If you delete a hard link or even the original file with which the hard link is associated, the remaining hard links will still be operational. There are two important restrictions concerning hard links. Firstly, hard links to a file must all reside on the same file system. Secondly, hard links can only point to files, therefore they may not point to directories. A symbolic link, also called symlink or soft link, is a pointer to a file name in its original location. If the original file associated with a symbolic link is deleted, the data of the file is lost. Consequently, all symbolic links pointing to the original file become broken or stale and will no longer work. To create a soft link, you need to use the -s option of ln. Soft links work with both files and directories, and they may also point to locations on other file systems. Study points. Explain briefly what the purpose of links is. Explain in your own words what the difference is between hard links and symbolic links. Use the ln command to create some hard links and use the ln-s command to create some symlinks. Use the commands ls-li and ls-l to find out more about the links you have created. Examine the directory /etc rc.d. Research the purpose of the links you find in the directories rc0.d through rc6.d. Where do these links point to? Read the ln man page. This is Jay from paulpolito.com, and thanks for watching this screencast about devices, Linux file system, and file system hierarchy standard. Until next time,